You sit in stillness and you listen, not to any sound in particular, but to the way moments seem to pass around you. It's not a rush, not a flood. It's more like a river on a quiet morning, smooth and unhurried, carrying leaves gently downstream. Time feels like that, a current you cannot see but can always sense. But here's the secret. Rivers are not always constant. Sometimes they race, quick and foaming over rocks. Sometimes they slow, spreading wide into calm pools. If you have ever stood by water, you know how its pace changes depending on where it flows. And in this way, time too can flow differently depending on where and how you are. Most days, you never notice it. Your heart beats, your breath moves in and out, your thoughts drift from one to the next. Clocks tick in regular patterns, and the sun arcs across the sky at what feels like the same speed every day. But underneath this familiar rhythm is a deeper truth. The pace of time is not fixed at all. It bends, it stretches, it contracts. You imagine holding a clock in your hands, a small, silver one with smooth ticking. You trust that every second is the same as the one before it. But somewhere else, another clock is ticking just slightly differently. Not because it is broken, but because time itself is not the same there. The thought is gentle but strange. You've always thought of time as a single, universal metronome, one that sets the beat for every heartbeat, every breath, every falling leaf in the world. And yet, here is the beginning of the journey, realizing that this great metronome does not exist. There is no single, perfect tick that the universe follows. Instead, each place, each motion, each condition has its own rhythm. It's like standing on the shore and watching two boats drift away from you, one caught in a fast current, the other in a slow swirl. They begin side by side, but after a while, they are no longer together. They have lived through different stretches of the river, just as people, planets, and even beams of light can live through different stretches of time. You remember a moment in your own life when time seemed to behave strangely. Perhaps it was during a long, slow afternoon, when minutes seemed to linger like soft clouds. Or perhaps it was during a rush of excitement, when hours seemed to vanish into a blur of laughter and movement. Of course, your watch hands kept moving in the same steady way, but your mind felt the difference. This is not the same as true time dilation, but it hints at a truth. Time is not always what it seems from within. In the physical world, this change in time's flow is not about mood or perception. It is built into the structure of the universe itself. It is tied to speed and to gravity and to the very fabric of space and time. But before we rush to the how, we sit here in the knowing that time can change. You take a slow breath and let this truth settle. The air fills your lungs, your chest rises, your body holds a breath for a moment, then it falls away. Inhale, exhale. Time, you realize, has its own breath too. It stretches long when space is calm, and it pulls in short when space is bent or when movement grows fierce. It's as though the universe is breathing with you, and you are breathing with it. Imagine that your life is a single path through a forest. You walk slowly, noticing the sunlight on the leaves, the quiet shift of shadows. In some parts of the path, the air feels heavy, and your steps feel slower. In others, the way is light, and you move with ease. All the while, your journey forward is guided not only by your own pace, but by the way the path itself curves and tilts. Time is that forest path. It changes as you move through it, even when you think it is straight. Now, think of the stars above you. They are not only points of light, they are clocks, too. Each star sends you its light from far away, and that light has taken years, even centuries, to reach your eyes. In a way, looking at the night sky is looking into the past. The more distant the star, the older the moment you are seeing. Some of those moments happened before you were born, before your grandparents were born, and yet they are here now, entering your gaze, as if the universe is folding its history into your present. This is the first doorway into the thought of traveling through time without moving. If the flow of time can change, then you can find ways, gentle, deliberate ways, to step into another pace of it. It may not be the kind of travel you see in stories, with flashing machines and sudden leaps into distant centuries. Instead, it is a subtler, quieter kind of journey, the kind where you remain still, but time itself shifts around you. You are a passenger already, whether you notice it or not. Right now, this very moment, the Earth is carrying you at thousands of kilometers per hour around the sun. The sun itself is drifting through the galaxy at even greater speeds. And all the while, your experience of seconds and minutes is shaped by where you are and how you are moving. Even now, your clock is not in perfect agreement with clock in a different part of the world or in the depths of space. You begin to feel it now, the subtle way the present is not as fixed as you once believed. Like a deep breath held for just a moment before it's released, the now is elastic. The seconds you hold are your own, and they do not pass quite the same way for anyone else. You sit again in your quiet place. The room is still, the air soft. Somewhere outside, the world moves in its many rhythms. The rush of traffic, the hush of leaves, the stretch of shadows. You are here, and yet you are also already in the next moment, carried there by the invisible current. You close your eyes and feel it, the slow breath of time. And as you feel it, you notice something else. If time is flexible, then it must be shaped by something, a reason hidden in the patterns of the universe. Who first saw this truth clearly? Who first dared to suggest that time was not absolute, that the river could change its speed? You lean toward that question, the way you might lean toward the edge of a story that has not yet been told. The question from before still lingers in the air. Who first dared to say that time is not fixed? You follow that thought as if walking through a quiet hallway lined with photographs. Each frame holds a face from history. People who looked at the world differently, who turned questions over in their minds like smooth stones in a river. And then near the far end you see him, not as the wild-haired caricature you've seen on T-shirts, but as a man sitting at a desk, his pen resting lightly in his hand. Albert Einstein. He is not speaking loudly. In fact, it feels like he is barely speaking at all, just a murmur, a gentle sharing of what he sees. And yet his voice carries across decades, because what he has to say changes how we understand the universe itself. He tells you, not with grand gestures, but with quiet certainty, that space and time are not separate things. They are threads of the same vast fabric, woven together so completely that you cannot pull one without tugging the other. We call it space-time, a word that sounds simple, but holds the weight of galaxies inside it. You imagine this fabric now, not a rough cloth, but something smooth and endless, stretching far beyond sight. The stars rest upon it. The planets roll across it, and every step you take is a tiny ripple through it. It is the invisible stage on which the universe moves. Einstein leans forward, his eyes bright in a way that feels both curious and kind. He tells you that mass, the very presence of something heavy, bends as fabric. A star, a planet. Even your own body presses into space-time, creating a subtle dip. And just as a marble rolling past a dent in a sheet will curve toward it, light and matter curve around these dips in space-time. But here's the part that feels almost like magic. When the fabric bends, time bends too. A clock sitting deep in the dip, near something massive, will tick more slowly than a clock farther away. And it's not the clock that's broken. It's that time itself is moving at a different pace there. You picture a great star now, bright and heavy in the darkness. Around it, space-time is stretched downward, like a hammock holding something precious. If you could place two identical clocks, one on the star's surface, one far away in the emptiness, you would see the difference. The one close to the star would tick slower, even though both are built the same way. Gravity does not just hold you down, it slows your journey through time. Einstein's voice does not rush. It is as if he knows this idea takes time to sink in, the way warm water soaks slowly into the skin. He waits while you sit with it. And then he speaks of another way to change time's flow: speed. Imagine a train, sleek and fast, racing along a track. Inside the train, you bounce a beam of light between two mirrors, up and down, up and down. To you, inside the train, the beam travels a simple vertical path. But to someone watching from the platform, the beam is not just moving up and down. It is moving diagonally, following the train's forward motion. Because the light must travel farther for the outside observer, and because light speed never changes, time inside the train must slow for both views to agree. You let this sink in. The faster you move, the more time stretches for you compared to someone standing still. It's as if speed lets you step sideways into another tempo, another rhythm of existence. Einstein smiles in your mind's eye, not triumphantly, but almost shyly, as though these truths are gifts he stumbled upon rather than invented. He reminds you that this isn't just theory. It's real, tested, and measurable. Satellites orbiting Earth must account for these shifts in time, both from their speed and from the weaker pull of gravity at their altitude. Without correcting for these differences, GPS systems would quickly lose accuracy, and the maps on your phone would lead you far astray. It is humbling to realize that the device in your pocket works because of these subtle truths about time, whispered by a man who once sat at a desk, thinking about trains and beams of light. You close your eyes and imagine space-time again. The smooth, dark fabric, the gentle curves and dips. You see a planet, serene and glowing in the quiet. Around it, time itself moves just a little more slowly, like a deep breath held for an extra moment. Farther out, away from its pull, the seconds flow more freely. And somewhere, moving at a fierce speed, a spacecraft glides, its crew living minutes that will not quite match those back home. Einstein does not ask you to memorize equations tonight. He only asks you to notice that time is not an unshakable, universal drumbeat. It is woven into the shape and movement of the universe, shifting in pace depending on where you are and how you move. In this, there's a kind of quiet beauty, a reminder that the world is more fluid than it appears. You think of your own life, your own days. You may not be traveling near the speed of light or standing on the surface of a massive star, yet you are still part of this fabric. Every second you live is shaped by the curves and flows of space-time. You are not separate from it. You are within it, moving along its contours. The thought is comforting. If time is flexible, it means the universe holds a softness, a willingness to bend. It means that your journey is not locked into one single rhythm, that there is space for variation, for wonder. Einstein's gentle whisper fades now, as if he said what he needed to say and trusts you to carry it forward. The hallway of photographs dissolves, and you are once again in the quiet, wrapped in the knowledge that time is alive, breathing, and responsive. And yet, the thought stirs in you. How does this bending of time feel in the real world? If you could stand in two places at once, one near the pull of gravity, one far from it, would you notice a difference? Would the ticking of a clock really change in your ears? You sense the answer waiting for you, carried not in equations, but in stories of mountains and valleys, of clocks that race and clocks that linger. The image a high peak forms in your mind. Crisp air, thin clouds, a clock resting quietly at its summit. You are still holding Einstein's whisper in your mind, the idea that gravity bends not just space, but time. It lingers like the faint scent of rain in the air, present even when the sky looks clear. To see it, you don't need to imagine black holes or distant galaxies. You only need to picture something much closer, much quieter, a mountain rising from the earth like a slow, steady breath turned to stone. At its base, the valley floor feels sheltered. The air is heavier here, carrying the scent of soil and water. The mountainsides rise steeply, and far above, the summit is hidden in drifting cloud. You imagine a clock resting here in the valley, ticking away in calm, even beats. Now, your mind carries you upward. Step by step, you climb. The air thins, each breath a little cooler, the view opening wide to reveal distant rivers and ridges. And there, at the very peak, you set down another clock, identical to the first, its hands gleaming in the sunlight. At first glance, the two clocks seem to keep perfect time. If you were to check them over a few minutes or even a few hours, you would find no difference at all. But wait longer. Let days pass. Let months slide quietly into years. And then you would see it. The mountain clock has gained a tiny lead. Not much, just a whisper a second. But a difference all the same. This is not a trick of the gears or flaw in design. It is gravity at work. Here in the valley, You are closer to the pull of Earth's mass. Gravity tugs on you a little more strongly, and that pull stretches not only on your muscles and bones, but on the very fabric of time. The stronger the gravity, the slower time passes. Up on the mountain, with less pull holding it back, the clock's seconds flow more freely. It feels strange to think that the higher you go, the faster you are moving through time, even if only by the smallest margin. But this is not just an idea. It has been measured. Physicists, with clocks more precise than the beat of a hummingbird's wings, have placed them at different heights and seen the effect. The higher clock always runs a little faster. You picture your own heartbeat now, steady and unhurried. It, too, is a clock, one shaped by every curve in space-time around you. When you are in the valley, your heart moves to the valley's pace. When you stand on the mountain, it beats to a slightly different rhythm, even though you cannot feel the change. It is humbling to realize that this happens all the time, everywhere on Earth. Someone living in a tall building is aging just a little faster than someone on the ground floor. Astronauts orbiting high above the Earth gain moments over those who remain below. The differences are so small that, for daily life, they mean nothing, but for the universe, they mean everything. This is a quiet truth Einstein showed us. Time's flow depends on where you stand. It is not a single universal current, but a series of streams, each with its own subtle speed. And gravity is one of the hands that turns the dial. You close your eyes and return to the mountain. The summit air is crisp, almost sweet. Cloud shadows drift lazily over the slopes below, and the valley seems far away, as though it belongs to another world entirely. The mountain clock ticks softly beside you. Somewhere down below, its twin ticks too, a fraction of a heartbeat behind. If you stayed here, lived here, your moments would quietly multiply compared to the valley. Perhaps after decades, you'll be ahead by only a blink, but it will be a blink that belongs to you alone. There's a kind of comfort in this thought. You're not just moving through time passively. Your place in the world is shaping your journey through it. Each step you take upward, each climb, each rise above the pull of gravity, all of it shifts your pace ever so slightly. And yet, the mountain is only the beginning. If such a small change in gravity can alter time here on Earth, what happens in places where gravity is far stronger? What if the pull is so intense that seconds stretch into years? You let your mind drift to that question, knowing the answer lies far beyond the calm slopes and gentle valleys. You are floating in the dark, but the dark is not empty. It hums, a low, steady sound, like the soft breath of the cosmos itself. Ahead of you stretches a beam of light, a thin, unwavering thread, spun from the heart of a star. You imagine stepping onto it, not walking, but riding, like a surfer leaning into the curve of a wave. Except the wave is made of pure speed. You begin slow, slower than a drifting leaf, slower than the turning of the moon's face. But speed is a hungry thing. Once it tastes motion, it wants more. The stars around you begin to blur. Their light stretches into long ribbons, as if the universe itself were being pulled. Like taffy in the hands of a cosmic baker, you feel the press of velocity against your skin, not as wind, for there is no air here, but as a deepening quiet, a silence so profound it seems to bend inward toward your thoughts. At first, seconds behave as they always have. One follows another, tapping softly on your mind's window. But as your speed climbs, those seconds grow strange. They stretch. They cling to you like a drop of honey refusing to fall. Time becomes viscous. You remember Einstein's whisper, that speed and time are lovers in a delicate dance. The faster you move through space, the slower you move through time. It is not a trick, not an illusion, but the way the universe keeps its balance. If you take more from space, it must take from time. Your vessel, real or imagined, is now kissing the edge of light speed. From the outside, to anyone watching, your journey is a slow unfurling. Years pass, decades even, but inside, you cradle only moments in your hands. Your heart beats in calm defiance of the rushing world around you. You could cross a galaxy, In what feels like a single afternoon, you could leave Earth in spring and arrive somewhere in the far future, before autumn has touched your hair. It's a strange kind of power, this bending of time, not the power to stop it, but to slip sideways through it, to take a shorter road, through the fabric of existence. You picture Earth, tiny now behind you, your friends, your family. They keep moving in their own time stream. You wave at them in your mind, but you know the truth. By the time you return, their faces may be older, their stories different. Perhaps some will have drifted entirely into the soft sea of memory. There's both ache and awe in this thought. Ache, because to travel far and fast is to leave behind. Awe, because in doing so, you become a keeper of futures that others will never see. The ship hums, or maybe it's only the hum of your blood, thrilled by the physics unfolding around you. You think of photons, those tireless runners, born from stars, living their entire lives at the speed you now approach. For them, there is no before and after, no tick of any clock. A photon leaves its birthplace and arrives at its destination in the same instant. From its own perspective, to ride light itself is to erase the very idea of duration. But you are not light, you are matter, and matter has rules. No matter how close you press to that cosmic limit, you will never quite touch it. The energy required climbs toward infinity, a mountain whose summit retreats. As you climb, still, in this almost light journey, you find something deeper than speed. You find perspective. Imagine holding a cloth stretched tight. Press your finger into it, and it curves inward. That curve is gravity, mass shaping the stage on which reality plays. Now imagine dragging your finger swiftly across that cloth. The shape changes, not because of mass alone, but because motion also bends the fabric beneath you. You are no longer a still weight upon the sheet, but a dart of force, reshaping the weave as you pass. From here, even your own body seems different. Your mass is no longer fixed. It grows with speed, a quiet swelling that makes each fraction of acceleration harder to win. This is the universe's gentle way of saying, you may dance with light, but you may not become it. You breathe, though breath here is only an image, to steady your mind. The beam ahead of you narrows, pulling your thoughts with it. Your sense of distance collapses. A star that was once a pinprick on a velvet backdrop now blooms into detail, its surface rippling like molten gold, its magnetic storms, flinging ribbons of plasma into space. All this vastness folds toward you as you ride the beam. It's not that space is shrinking, it's that your path through time is changing the way space greets you. You wonder what it would feel like to stop suddenly, to release speed, and fall back into the slower river where everyone else swims. Would the silence break? Would the stars snap back to their familiar, still faces? Would you find yourself homesick for the rush, for the honey-fixed seconds, and the soft bend of light? But you do not stop. Not yet. You stay with the beam, letting its edge blur into the very air of your mind. Here, thought itself seems to move differently, stretching and folding, the way space does. Ideas arrive from far ahead, as if you are catching whispers, sent from the very mouth of the future. Perhaps that is what speed truly is. Not motion through a place, but motion toward possibility, a way of leaning into tomorrow before it arrives. You feel the weight of this understanding settle into you, not as a burden, but as a kind of luminous stone, smooth and warm. You think of the travelers who might come after you, generations who will master this dance and make it their own. Perhaps they will not fear the distance between stars. Perhaps they will carry whole worlds in the palms of their hands. You close your eyes. The beam becomes a line of music, and you are a note sliding effortlessly along it. Behind you, history. Ahead, a future tilted gently toward you. by the curve of speed. The hum grows softer now. You imagine yourself drifting slightly off the beam, letting its light wash past, like a river you've been swimming in. For a long, beautiful time, your body feels a shift first, a loosening, a small surrender to slower clocks. But your mind is still racing ahead, still tasting the strange sweetness of having held more of the future than the present was willing to give. And somewhere ahead, just beyond the final shimmer of this ride, waits a question, not about speed, but about what it means to stand still. When the universe is always in motion, you float in a soft suspension, the hum of the station your constant heartbeat. There is no up or down here, only the gentle press of air, the faint rattle of distant machinery, and the endless black ocean beyond your window. Earth turns silently below, a swirl of clouds and continents painted on a deep blue sphere. You feel both far away and impossibly close. Every 90 minutes, you circle the entire planet. Sunrises and sunsets pass like the slow blink of a giant eye. Golden light floods your cabin, then slips away, replaced by the deep velvet of night. Time here is not the same as it is on Earth. It is not marked by clocks on walls, but by orbits and shadows. You know, of course, the science of what is happening to you. You have studied it, rehearsed it, explained it, but knowing it and feeling it are different things. Every tick of your watch matches the rhythm of those on Earth. Yet here, high above, your watch will complete slightly fewer ticks in the same Earth time than theirs. Not by much, just a whisper, but enough that you will carry this difference back with you. It is Einstein's special relativity playing quietly in the background of your life. You are moving fast, 17,000 miles per hour around the planet. And in the language of physics, motion and time are partners in a strange, unbreakable dance. The faster you move through space, the slower you move through time. Down there, people's hearts beat ever so slightly quicker. Their cells age a fraction more swiftly. Their moments flow just a little faster. The difference is tiny, milliseconds over months, but it is real. You are, by the smallest margin, younger than you would have been had you stayed on Earth. Younger than your twin, if you had one. Younger than your friends, your family, your past self who never left the ground. It is not a kind of youth you can see in the mirror. Your hair will still have the same streak of silver. Your eyes will still carry the same creases from years of laughter and sunlight. But deep inside your cells, in the way atoms tick like quiet metronomes, you are fractionally behind them, a secret that only physics, and perhaps you, will ever truly know. In the stillness, you think about what it means. You are not cheating time. You are not outrunning age. You are simply obeying the rules of the universe, rules that care nothing for pride or vanity, but everything for motion, mass, and light. Here, you are both part of the great experiment and one of its rare witnesses. The station's metal skin vibrates softly, carrying the ghost of distant machinery through your fingertips. The air smells faintly metallic, recycled 1,000 times over. You push gently off the wall, gliding past racks of equipment, notebooks floating in plastic sleeves, cables twisting like vines in a quiet forest. Outside the thick window glass, space is silent. A black, so pure it seems to swallow thought. You remember the first time you learned of this effect. You were younger, sitting in a lecture hall, and someone explained the twin paradox. If one twin travels far into space at near light speed and returns, they will be younger than the one who stayed home. It sounded like science fiction, but it was simply the math of relativity. Now, you are not a thought experiment. You are living it. Some nights, when Earth is bathed in shadow, you stare into the stars and wonder about their own time. Each one is a sun, living its life in a rhythm dictated by gravity and fusion, its light stretching across light years to meet your eyes. The universe, you realize, does not have a single clock. Each star, each planet, each traveler through space carries their own. Time, it seems, is not the steady river you once imagined. It is more like a vast, shimmering lake, and each of us moves across its surface at a slightly different pace. You are just one small ripple, drifting your own direction, carrying your own measure of the moments you are given. When you return to Earth, You will stand on solid ground and feel its gravity pull you back into familiar flow. You will walk among people whose lives have been moving just a shade faster. No one will notice the difference. No celebration will mark the milliseconds you have gained. And yet, you will feel it. The quiet knowledge that, for a short time, you lived in a different rhythm. You imagine stepping off the spacecraft, feeling the weight of your body again, smelling the scent of rain-soaked soil or the salt of the sea. You will smile at loved ones who have aged just as you have. Almost, but not quite. It will be your private truth, something you keep like a smooth stone in your pocket, turning it over in your mind when you want to remember what it was to live among the stars. Sometimes you wonder if this is a real treasure of space travel, not the photographs or the experiments, not the grand achievements or the headlines, but the subtle, invisible change you carry inside. A reminder that the universe is stranger than it appears, that even something as constant as time can be bent, stretched, and experienced differently. The hum of the station surrounds you. Outside, the sun is rising again, turning the curve of the earth gold. You float in the quiet, feeling the seconds pass at their gentle, altered pace. Somewhere below, someone is looking up at the sky, wondering what it's like to be here. And you think, it's like holding a secret the size of a galaxy. You turn slowly in the air, catching the glint of light off a panel of instruments. The numbers there mean little to anyone else. But to you, they are part of the equation, part of the reason your time flows differently. You imagine explaining it to someone, the way speed and gravity can sculpt the passing of moments. You would tell them that this isn't magic. It's the way the universe works, everywhere for everyone. It's just that here above the spinning earth, you can feel it in your bones. Far below, life continues. Tides shift, winds cross continents. People laugh, work, sleep, dream, their hearts beating in the steady tempo of earth time. Up here, your heart keeps a slightly different beat. It's a rhythm that will fade when you return, blending back into the common song. But for now, you are alone in this rare tempo, your days and nights braided with silence and starlight. Perhaps the most beautiful part is knowing that you did not have to chase this difference. You simply lived your life in motion, and the universe gave it to you unasked. You close your eyes, letting the hum of the station lull you. Outside, the world turns. Inside, time drifts. Somewhere ahead lies a return, and with it, the strange reunion of two different clocks. And perhaps beyond that lies an even greater secret, one that doesn't just slow time, but reshapes it entirely. You are drifting towards something that does not move. It waits, patient, unblinking, a shadow stitched into the fabric of space. A black hole, not a hole where a tear opens in fabric, but a place where the fabric folds so steeply downward that nothing can climb back out. It does not shine, and yet it is the brightest object you will never see. Around it, light bends in obedient arcs, pulled into spirals by an invisible hand. The stars behind it warp, their positions smeared into circles. The gravitational lensing of its presence. You have the sense that you are not falling toward it, but rather that space itself is flowing into it, carrying you along. You remember the way water moves toward a drain, not because the drain pulls the water in, but because the water's own currents guide it there. Here, it is not water, but space-time itself flowing toward the center. You ride those currents. From a distance, a black hole can be mistaken for a star that has simply stopped shining. But this is no sleeping star. It is the grave of one, a collapsed core so dense that the concept of surface no longer applies. Matter, crushed beyond atoms, beyond even the particles that make atoms, pressed into a point so small that our language fails. Physicists call it a singularity. You feel the word in your mind. Singular, the only one of its kind. It is not simply dense. It is infinite in its density. Time behaves strangely here. From the safety of a far-off orbit, an observer would see you slow down as you approach. Your steps, your gestures, your blinking, all stretching longer and longer until, to them, you appear frozen at the edge of the black hole's event horizon. That edge is not a physical surface. It is a boundary in time, the point where coming back is no longer part of the story. From your own perspective, nothing feels different. Your heartbeat continues at its steady rhythm. Your thoughts arrive one after the other. You would never know that to the outside world. Centuries might pass while you take a single breath. You think of it like this. Imagine you are walking down a road toward a city. To you, each step is the same as the last. But to someone watching from far away, the road ahead is stretching longer with every step you take until your forward progress appears to stop entirely. The black hole stretches time in the same way. The light around you is changing. It is reddening, dimming. Not because the black hole steals its color, but because the space between you and the source is stretching. This is gravitational redshift, a silent stretching of the light waves as they climb away from the deep well of gravity. You are seeing the universe through a filter of time itself. Closer now, you pass through the region where the light of infalling matter blazes. A disk of superheated gas and dust orbits the black hole, an accretion disk, glowing from friction, each particle colliding with others in a frantic spiral. This is the only part of a black hole you can truly see. Not the hole itself, but the matter it devours, shining in its final moments. Some of it escapes in jets along the black hole's poles, thin streams of particles accelerated to nearly the speed of light. These jets can reach across light years, stitching the black hole's presence into the tapestry of its galaxy. You drift closer still, and the pull becomes an ache in your bones, not a physical tug, but a feeling in the rhythm of your thoughts. The space around you feels curved, like walking in a dream where each step forward is heavier than the last. Your clock ticks steadily, but you can sense that the outside universe's clock is racing ahead. You imagine people far away aging faster, civilizations rising and falling while you remain in your slow descent. You are now within sight of the event horizon. It is not a wall, not a door, just an invisible veil. You could pass through it without a sound, without resistance. But once you cross, every path through space-time curves inward, leading only to the singularity. Inside, all directions point toward the center. In your mind, you see an ant walking on a sheet of paper. Outside the event horizon, the ant can walk in any direction. Inside, no matter which way it turns, the paper slopes toward a single point. The slope here is space-time itself. You think about what would happen to you. If the black hole is small, tidal forces, the difference in gravity between your head and your feet would stretch you, spaghettify you into a thin stream of atoms long before you reach the singularity. If the black hole is supermassive, those forces would be gentle at the horizon. You could pass through unharmed, only to find the singularity waiting in your future like a slow, inevitable sunrise. From the outside, your journey is almost over before it begins. They see you reach the horizon, slow to a crawl, and freeze, a statue of light fading into background glow. But for you, the story continues. Your fall is smooth, inevitable, without the option of return. Inside, the rules we know no longer apply. Space and time trade roles. Time becomes a direction you cannot stop moving toward, the singularity, while space becomes a more fluid idea. No force, no engine, no pleading can turn you back. You realize that the black hole does not pull you. It simply curves reality so completely that all roads end in the same place. It is less a predator and more a valley in the landscape of existence, a valley so deep it pierces through the map entirely. The singularity itself is hidden from you. It is not a dot in the center that you can point to. It is a place where our equations collapse, where our understanding stops. The closer you get, the less your familiar concepts of distance and time mean anything. You think about the universe outside. Far away, galaxies spin, stars are born, planets orbit quietly. Light from those places still streams toward the black hole, but here, at the edge of ultimate gravity, it feels almost irrelevant. You are part of a smaller story now, one that ends in a place without witnesses. You wonder, if you could send a message back, what would it say? A final image, a thought, a fragment of what it feels like to be here. But the truth is, no message can escape. The event horizon is not just a boundary for matter. It is a boundary for information itself. Whatever passes through becomes unknowable to the outside world. In the quiet of your descent, you begin to think of the black hole differently, not as an end, but as a kind of archive, a place where the past is stored in ways we cannot retrieve. Everything it swallows still exists, in some sense, inside the horizon. Perhaps, in the far future, the universe will find a way to read those pages again. The thought is strangely comforting. Even in the deepest gravity, even in the absence of light, there's a possibility that nothing is truly lost, only hidden. You drift further, your surroundings bending more dramatically, the stars smearing into arcs, the black hole shadow expanding until it's all you see. You are falling toward a point that is everywhere at once, yet nowhere you can name. Somewhere beyond your sight, the singularity waits. Somewhere beyond that, perhaps, there are answers, not just what happens here, but to what happens anywhere that gravity rules without limit. And as you think of that, another question stirs quietly at the back of your mind. If the black hole hides so much, then what might hide in the spaces where gravity does not reign? You are standing at a quiet train station in the early morning mist. The sky is soft with the pale light of dawn, and the air carries the faint hum of distant movement. Two figures approach you from opposite directions. They are twins. You can see it instantly in the way their faces echo one another, in the curve of their smiles, in the quiet familiarity in their eyes. One twin, let's call him Rami, has been here the whole time, rooted to this place, living a life in steady rhythms. Sunrise, sunset, seasons passing like a slow-turning wheel. The other, Sammy, has just returned from a journey you can hardly imagine, a voyage at near light speed across the deep reaches of space. They were born at the same moment, under the same sky, and yet, as they now stand side by side, something is different. It is subtle at first. The difference is not in the clothing, not in the stance, but in the age. Rami's face carries the marks of years. Soft lines at the corners of his eyes, the gentle weight of time resting on his skin. Sammy, in contrast, still holds the youthful light of someone who has lived fewer days. It is as if the two of them have been keeping separate calendars, hidden from one another. This is not magic. It is not trickery. It is the truth of a universe, the truth of time dilation. Time, you've been told, is constant. A clock ticks the same for everyone. But that is only the everyday truth, the one that works well enough for walking to the market or boiling water for tea. When you move through the universe at speeds close to that of light, time begins to bend around you like wind against your skin. Your clock, your heartbeats, your very experience of now. All of it changes compared to someone who stays behind. Imagine you and your twin each carry an identical pocket watch, perfectly synchronized. You step aboard a spacecraft and it begins to accelerate, pulling away from Earth until your speed is a fraction less than the speed of light. To you, the seconds on your watch seem to pass normally. You feel no slowing, no stretching. You sip water, you sleep, you wake, and your body tells you the rhythm is unchanged. But when you return and compare your watch to your twins, the hands on yours have moved more slowly. For you, less time has passed. It is not just the watch. Your body, your cells, your memories, all of them are younger than your twins. You have experienced fewer moments. Your life has run along a shorter thread, even though you were apart for what seemed like many years. This is a famous twin paradox. Though it feels like a paradox, it is simply the universe following the rules written into the fabric of space and time by Einstein's theory of relativity. Time is not a river flowing at the same pace for all boats. It is more like a landscape with valleys and slopes, where your path can be shorter or longer depending on how you travel. Velocity, especially extreme velocity, tilts that landscape. The faster you move through space, the slower you move through time. This slowing is invisible to you, because every atom in your body slows down together. You cannot feel it. It is only when you reunite with someone who's been on a different path that the difference becomes clear. The thought is quietly humbling. It means there is no single universal now. There is your now, and your twins now, and each belongs only to the one living it. You think back to Rami and Sammy, standing there at the station. They smile at one another, but their smiles carry different histories. For Rami, the years without Sammy were long. Birthdays passed, seasons changed, gray hairs appeared. For Sammy, it feels as though the parting happened just yesterday. To Sammy, the gap is almost nothing. The same event, two completely different experiences of time. If you could see time not as numbers on a clock, but as a fabric, you might notice that Sammy's path through is stretched and smooth, while Rami's is full and dense with passing seconds. Their lives are still connected, threads woven together at the beginning and end, but the weaving in between has different patterns. In this way, time dilation is not just physics. It is also a story about perspective. It says, you can live beside someone your entire life, yet your journeys through time are never exactly the same. Every step you take, every movement, every pull of gravity on your body shapes your personal rhythm of existence. We all carry a clock inside us, and none of them keep precisely the same beat. And so, when you look at someone you love, you are not just seeing who they are in this moment. You are seeing the shape of their time, the unique curve of their journey. Two people can share the same room, the same laughter, the same silence, yet live in slightly different versions of the universe's unfolding. You realize that this is true even here on Earth, at ordinary speeds. Your time passes a tiny bit differently from someone who lives high in the mountains, where gravity's pull is slightly weaker. It passes differently from a person who works aboard the International Space Station, circling the planet at thousands of kilometers per hour. The difference is so small, it is almost impossible to notice, but it is there, an invisible signature written into the clock of your life. This is why scientists place atomic clocks on airplanes and compare them to those on the ground, and they find that the times do not match exactly. They are not faulty clocks. They are simply obeying the deep truth of the cosmos. As the twins embrace at the station, you feel a quiet awe. It is one thing to read about equations and theories. It is another to see it in the gentle curve of a younger face, in the older eyes that look back with love. The universe has many ways of telling its secrets, and sometimes it chooses the language of human reunion. And as you watch them walk away together, you can't help but think, if velocity can bend time, what else can shape it? If movement through space can alter the very pace of your days, then perhaps there are places in the universe where time behaves even more strangely, where gravity itself pulls so fiercely on the fabric of reality that time nearly stops. You step inside, and the air greets you with a hush so complete that your own heartbeat feels loud. The room is neither dark nor bright. It glows softly, as though the walls have learned how to hold light without letting it spill. The floor is cool under your feet, and somewhere, faintly, you hear the hum of electricity, steady and calm. It is here that light itself is trapped, not to be dimmed, but to be studied. Two mirrors face each other across a narrow corridor of air, so perfectly aligned that the beams between them do not waver. The light bounces back and forth, a silent conversation carried on at nearly 300,000 kilometers per second. You watch it move, though you cannot truly see its movement. It is too fast for the eye, too patient for the heart to rush toward. In its path, time is measured with an accuracy that feels almost unreal. This is no ordinary clock. There are no hands sweeping in circles, no digits counting down the seconds. Instead, the oscillations of light become the heartbeat of the measurement. Each cycle a whisper of now, now, now. An optical clock, they call it, a timekeeper so precise it would take billions of years to lose even a single second. The scientists here move quietly, as though afraid that sound might disturb the balance. One adjusts the position of a mirror by less than the width of a human hair. Another peers at a monitor, watching graphs rise and fall in gentle waves. They are not just looking at light. They are looking at time itself, caught in the act of existing. You stand closer, your eyes follow an invisible path between mirrors. It feels almost sacred, as if this beam is more than a tool. It is a messenger, a reminder that time is not an abstract thing invented, but a rhythm the universe has always played. Underscore. Light is a perfect companion for such work. It never tires. It does not rust or warp. It travels at the same speed, no matter how you chase it. But even light is not immune to the universe's quiet games. When a clock like this is lifted higher above Earth's surface, gravity's pull lessens, and time flows a little faster. Lower it into a valley, and the weight of gravity slows it down. This is not a trick of the equipment. It is Einstein's general relativity, laid bare in the faint difference between ticks. Here, in this laboratory, that theory is not a distant equation in a textbook. It is a reality they can measure, a truth you can almost see. One of the scientists smiles faintly as she explains it. Two clocks, separated by just a meter in height, will tick at different rates, she says. The difference is so small it would escape any human sense. But the light catches it, records it, and makes it visible. It's as though time itself leans differently on each clock, depending on where it stands in the landscape of gravity. You think of this as you glance at your own wristwatch. Its ticking suddenly feels clumsy, almost too human. Your watch measures moments in steps and jumps, while these beams of light measure them in breaths too fine to imagine. Here, seconds are not just counted. They are studied, weighed, and compared until even their smallest changes are understood. There's something deeply human in this work, not just a desire to measure, but the need to listen. The same curiosity that once made people track shadows on stone walls now makes them trap light between mirrors. The tools have changed, but the question has not. What is time, and how does it move around us? In a far corner of the room, you see a row of older clocks, some mechanical, some atomic. They are like ancestors, honored and remembered. Each one a step in the journey to this moment, pendulums swinging in graceful arcs, quartz crystals vibrating with mechanical perfection, cesium atoms resonating in microwaves, and now light, pure and steady, carrying time on its back. You realize this place is more than a lab. It is a museum of precision, a cathedral to timekeeping, where each instrument has added a verse to the song of measurement. One researcher invites you to look into a monitor linked to the optical system. The data streams in, numbers flowing like a digital river. You don't need to read them to understand. What you see is constancy, the kind of steadiness you rarely find in human life. It is not the steadiness of boredom, but a devotion, like a candle that never flickers, no matter the wind. They tell you that this technology can track the slow rising of continents, the drift of tectonic plates. It can sense changes in gravity so subtle they hint at underground water flowing miles away. Time, it turns out, can be used to map the Earth, to listen to the planet's heartbeat. You walk slowly around the lab, feeling as though you stepped into the pause between two notes in a song. It is not lifeless here. It is deeply alive in a way that has nothing to do with movement or noise. Every mirror, every beam, every breath of the people here is part of the same patience. One corner holds a smaller setup, a portable version of the optical clock. It's small enough to travel, they tell you, yet accurate enough to notice the time difference between mountain peaks and valleys. Imagine carrying such a thing into the wild, they say, and measuring how time stretches and contracts across the landscape. The thought stays with you. Time as a topography, a map you cannot see with your eyes, but one you can trace if you know how to listen. And then you realize this is not just about clocks. It is about trust. We trust that the light will keep moving. We trust that the mirrors will hold their position. We trust that even in the smallest changes, there is something to be learned. Light and time are in conversation here, and you are an eavesdropper, leaning in gently. The light asks time, "How steady are you?" And time replies, "Steadier than you think, but not the same everywhere." It's a strange comfort. That time is both universal and personal. It flows through galaxies, and yet bends slightly when you climb a flight of stairs. It is constant in principle, but variable in detail. And we are the only creatures, as far as we know, who have chosen to notice. Underscore, 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 underscore. You close your eyes for a moment. In the darkness, you picture the beam of light still moving between mirrors, counting moments too fine for your senses. When you open them again, the room has not changed, but you have. You now feel the weight of precision, not heavy, but grounding, like the feel of the earth beneath your feet. This laboratory is a reminder that the future is built not only by leaps of discovery, but by the quiet persistence of looking more closely. That to understand the universe, sometimes you must not chase it, but wait for it to reveal itself in its own rhythm. You take one last look at the mirrors, the beam, the stillness. You know that when you leave, time will still move as it always has. But now, you will move through it differently, aware of the subtle ways it bends, stretches, and keeps its secrets. And yet, there's one question that lingers, soft but insistent. If we can measure time so precisely here, in the safe stillness of a lab, what happens when we try to take that measurement to the very edges of the universe? You live in a river you cannot see. It does not splash against your skin or ripple under the wind. It has no sound, yet it carries you, all of you, from the moment you open your eyes to the moment you close them again. This river is time. And unlike the rivers of Earth, it does not always flow at the same speed. You may think of time as a constant drumbeat, tick, 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 but it is more like a song whose tempo changes with the landscape it moves through. Sometimes the notes stretch, slow and drawn out. Sometimes they quicken, skipping ahead like light feet across stone. You live inside this music, but you do not notice the changes because your entire world dances with you. Consider this. Above your head, satellites circle the Earth. They are close to the planet, but not so close that they feel the deep pull of its gravity as strongly as you do here on the ground. Out there, in the thinner pull, time flows a little faster for them. Not much, just billions of a second faster each day, but enough that without correction, your GPS would slowly become useless. You would ask for directions, and your phone would point you to an empty field instead of the cafe. So the engineers correct for it. Every satellite carries the awareness of this bend in time, adjusting its heartbeat so it stays in step with yours. But it works in the other direction, too. When you ride in an airplane, moving fast above the curve of the Earth, your clock runs just a little slower compared to someone standing still. The difference is small, too small to notice without the sharp eyes of physics, but it is there. You may have sat beside the window, looking down at the patchwork of rivers and roads, not knowing that for those hours in the sky, you were living in a slightly different present than the people waiting for you on the ground. It is not only machines and airplanes. It is you, always, your heartbeat, the time between blinks, the stretch of breath. All of these are happening within a gentle shifting of time that depends on where you are, how you move, and how close you are to the deep wells of gravity that the universe. The deeper the well, the slower the flow. Imagine standing on the surface of a neutron star. If you could somehow survive its crushing gravity, your seconds that would crawl compared to the seconds of someone far away in the emptiness between galaxies. From their view, you would seem frozen, moving through molasses. From your view, they would seem to rush ahead, living weeks or months while you took a single breath. The same is true in softer ways on Earth. High in the mountains, time flows a little faster. Down in a valley, a little slower. The change is so small you could live 1,000 lives without feeling it, but physics feels it. And when physics feels something, it keeps the record forever. You are already stretched across these different flows. Think of your family spread across the world, one in New York, one in Islamabad, one flying to Tokyo. Each is living in slightly different rivers of time, yet you all speak as though you share the same moment. You do share it, in the way sailors share a horizon, each seeing